In this video I'm going to be talking about rational exponents. I am specifically making this video for the Math 105 class at IUK, and it covers their section 7-2. However, anybody that would be working with rational exponents, everything that I say is going to be applicable to you as well. Alright, and I might make a special note that this is part 2 of 2 videos that kind of go together. In the first video I went through 3 specific definitions of how you deal with rational exponents with some examples for each one of those, and then in this one we're going to just review a little bit of our laws of exponents and then just kind of put everything together from both videos and how to simplify problems. Alright, to start with, you've got to be able to know your laws of exponents. You initially learn these with integers for the most part as your exponents. All of those exact same rules apply if you have a rational exponent. So just real quickly to go over those rules again, when multiplying like bases we add the exponents, so that's what this rule shows right here. If you've got a base that's raised to an exponent that's raised to another exponent, power raised to a power in other words, you multiply those two exponents. Whenever you are dividing bases, then I can take that exponent and put it to both the numerator and the denominator, so that would be an a to the n over b to the n. If I'm dividing like bases, I can subtract the exponents, which is what that rule shows right there. And then this one is, if I am multiplying a variety of things, then I've got to remember and take that exponent and multiply it by both of the exponents that are on each of those bases. So that would make this an a to the n, b to the n. Alright, so that was just a real quick review of just your basic laws of exponents, which you're going to have a command on, a good command on, to be able to do rational exponents with this. Okay, so 3 little examples of where we're just dealing with rational exponents. Okay, suppose the directions say no more than simplify. Alright, you see those rational exponents floating around different places. Alright, so you just kind of look and see which kind of rule are you looking at here. This is when multiplying like bases. So when multiplying like bases, add those exponents. So 1/7 and 4/7 is a 5/7. So 6 to the 5/7. Alright, and it doesn't say anything about going any farther than that. We can leave our answers as these rational exponents. Okay, now this one I am dividing like bases. So when we divide like bases, we subtract those exponents. Alright, now those coefficients, we're going to treat those just like regular numbers. So we're going to go 32 divided by 16. Alright, that's going to give me a 2. When I divide those like bases and subtract the exponents, I'm going to have the same like base. Alright, 1/2 minus 3/4. You've got to do it in that order. That's going to give you a negative 1/4. Okay, and then from the first video we learned how to get rid of negative exponents. Basically all you have to do is move them to the denominator. So in this case, this x to the negative 1/4, this is going to get moved to the denominator, but that 2 is going to stay in the numerator, that coefficient. So then I'm going to have 2 over an x to a positive 1/4. And then here in this last example, this is an example of power raised to a power, but with 2 bases inside and 2 sets of exponents there. So on this one, you've just got to remember that that 1/2 has to be multiplied by the negative 2/5. It also has to be multiplied by that 1/3. Okay, so then that's going to give me an x to the negative 2/10 and a y to the 1/6. Okay, now anytime you end up with a fraction that can be reduced, probably need to go ahead and reduce that. Okay, so then I'm going to have an x to the negative 1/5 and a y to the 1/6. Alright, and now I'm to the place where, okay, I've got a negative exponent, so just like we had with this negative exponent up here, we moved it to the bottom. Okay, so that's the only thing that's going to get moved to the bottom. Alright, so then the y to the 1/6 is going to stay in our numerator. So y to the 1/6, moving this to the denominator, making it positive x to the 1/5. Alright, so 3 nice little examples there, just kind of reviewing those laws of exponents and dealing with them as rational exponents as opposed to integers. Alright, now we need to get to where we're using everything in both these 2 videos that I've made, and you're just going to apply everything to simplifying these higher level radicals. Alright, the directions are going to be very specific. They're going to say use rational exponents to simplify. Alright, this is just a method of how you can simplify higher order radicals, and it makes sense, and especially when you've been working with those rational exponents for such a long time. We are going to assume that all variables represent non-negative numbers, so we're not going to deal with any absolute values or anything. Okay. Alright, so for this one, I'm going to rewrite this using my different rules that I've shown in the two videos. Now, I'm going to look at this very carefully before I start. The cube root of 27. Alright, well, the cube root of 27 is 3, so I'm definitely going to just want to separate these into two separate things, because my 27 is being multiplied by that x to the 15th. So if I do the cube root of 27, and just leave it since I know that I can answer that out. Then on this x to the 15th, and it's the cube root of it, rewrite that in fraction, with an exponent, so x to the 15 over 3. Alright, and like I said, this is probably the easiest because the cube root of 27 just gives you a 3, and then now I can take a look at that rational exponent right there. 15 divided by 3 is a nice little 5, so then x to the 5th. Alright, it just makes a really nice, simple way to simplify these radicals. Alright, now on this one, I've got 2 in here. Now, technically, depends on, if you want to show absolutely every step. I think I will show absolutely every step here. Technically, everything in here is to the first power. Alright, so then when I take this and turn it into with a rational exponent, rewrite it like that, I'm going to have an x to the 4th, a y squared, and that's going to be raised to the 1/8 power. Okay, now, implementing those rules for rational exponents means I've got to multiply that 1/8 by both of those exponents in there, and then I'm going to have an x to the 4 over 8 and a y raised to the 2 over 8. Now, a lot of people can go straight from this step to this step without putting this extra step in there, because you can just tell that that's going to be an exponent of 1, so it makes it really easy. 4 over 8, 2 over 8. So either way, you can leave that step out right there. Alright, now both of those two fractions I can reduce, so I'm going to go x to the, let's go ahead and leave it 2/4 because I want my denominators to stay the same, so then I can do like a 4th root. Okay, let's rewrite this with a power of 1/4. So if I did that, then I'd have an x squared y raised to the 1/4. Now that I've got that, now I can do the 4th root. So 4th root of an x squared y. And as you begin to do more of these, you're going to realize, oh yeah, if I've got the same bases on here, this is going to make it a whole lot easier when I go to pull things out like that. Alright, now you could encounter a problem that has, like a cube root and then a square root, nested radicals like that. I would recommend working on the inside first and then see what we've got. So I'm going to leave the cube root alone, and I'm just going to change that inside one to x to the 1/2. Alright, now, depending on how many steps you want to show here, alright, if I think of it like this, this is being raised to the first power, so then I can rewrite this as an x to the 1/2 raised to the 1/3, and now I've got power raised to a power, so then I've got an x to the 1/6, and since we are trying to simplify the radical, we'll put it back in radical notation here, 6th root of x. Okay, and granted, this is, some of you are going to be able to get to this a lot quicker, alright, but if the directions actually want you to use those rational exponents, then you need to show that work to see how you got to that 6th root of x. Okay, let's do 2 more examples, just trying to encounter as many of those different laws of exponents that I can here. Alright, so let's do the 6th root of 2x raised to the 4th. Alright, so on this one, everything there is my base, so then I can rewrite as 2x raised to the 4 over 6. Alright, let's take that fraction now and reduce it. So 2x raised to the 2/3. Okay, now I'm going to implement the power raised to a power. Both those have 1s. So when I multiply by each of those, I'm going to have 2 to the 2/3 times an x to the 2/3. Alright, now I need to go into radical form with this one. So this is going to be the cube root of 2 squared. So cube root of 2 squared. And then this one's just going to be the cube root of x squared, which we can't do anything with. Alright, this one I can multiply out. 2 squared is going to be 4. They both have the same radical there, so I can write it as 1 radical cube root of 4x squared. Okay, so lots of different rules on that one being implemented. Okay, now on this last example, alright, again, how many steps do you want to put in there? Okay, if you want to put a parentheses around this with a 1 and put a parentheses around that with a 1 and have that extra step, you can. You'd have that power raised to a power. If not, and if you're getting a little bit better at this point, then you can just automatically go to a x to the 5/4 and a y to the 5/4 all over an x to the 1/2 and a y to the 1/2. Alright, now I'm dividing like bases, so that means I've got to subtract each one of those. 5/4 minus 1/2 on both of them will be the exact same thing. So then I'm going to have an x to the 3/4 and a y to the 3/4. Alright, and both of them already having that 4th root there, so then I can go the 4th root of x to the 3rd, y to the 3rd. Alright, so just several examples here in this second video trying to implement all of the different rules that you're shown in section 5-2 for the Math 105 students. Alright, and in general, just how you can use rational exponents to simplify higher order radicals. Definitely thanks for watching, and be sure to subscribe to the channel. Thanks.